This presentation is delivered by the Stanford Center for Professional Development.
And now let's get started. Today I'm joined by two of my esteemed colleagues, Dr. Dave Beach and Kurt Beiter of the Stanford School of Engineering. Dave Beach is a professor of mechanical engineering and director of the Product Realization Laboratory at Stanford University, which provides 950 students annually with hands-on experience in product definition, conceptual design, detailed design, and prototype creation. The laboratory offers courses, coaches, mentors, and tools in support of integrated product creation. It has engendered many new companies which design, manufacture, and distribute products in diverse domains, including alternative energy systems, automated genomics laboratory equipment, haptic devices, medical devices, sporting goods, transportation products, and underwater imaging equipment. Professor Beach's goal is to provide his students strength in tacit knowledge, which derives from the hands-on synthesis of design, prototype building, presentation, and criticism. The resulting judgment and instinct regarding materials, devices, materials transformation process, and design process complements classical analytical engineering education to create superior engineers. Kurt Beiter is an acting associate professor of mechanical engineering and director of manufacturing modeling lab here at Stanford University. He has been an integral part of the Design for Manufacturing research and teaching team, addressing the key issues of competitive product development. The design manufacturing course sequence was developed to meet the needs of world-class organizations, and over the years, its faculty has partnered with many companies such as Applied Materials, Cisco, Harley-Davidson, and Toshiba. Dr. Beiter's research interests focus on design for manufacturing, design for robustness, life cycle design, probabilistic design, system reliability, and product innovation. Gentlemen, thank you for being with us today.
Slava, thank you very much for that generous introduction. Kurt and I are here this morning to discuss a pair of courses. This is an experiment for us. We haven't tried this duet before, and I'm really looking forward to it. Kurt is going to talk to you about Design for Manufacturability, ME 317, A and B, right? And I'm going to talk to you about Good Products, Bad Products, which is a single quarter course, ME 314. Let me lead off. Good Products, Bad Products takes as its bumper sticker, if you can measure it, we're not interested in it. That's contrary to the usual view of quality, which is a very detailed, very intensive, very energetic, very creative adventure in reducing variability. We understand very well in Good Products, Bad Products that until you've reduced variability in your manufacturing process, there's not much point in talking about all the things that go on in ME 314. What does go on in ME 314 is an attempt to help engineers understand the human values associated with successful designs, topics such as human fit, craftsmanship, needs and emotions, elegance and sophistication, cultural values, symbolism, and global constraints. And this slide is intended to be an iconic image for needs and emotion. How about joy of flying? In order to enjoy flying, most human beings need to do something different than jump off the garage roof and flap their arms. So we, as a species, have invented kites, balloons, dirigibles, blimps, airplanes, rocket ships, space shuttles, and all kinds of other ways to become airborne, trampolines, noteworthy among them, and particularly from a value point of view. This is the Icon A5. It's an aircraft which is responding to a new category promulgated by the Federal Aviation Association about 5 years ago, and its purpose is an unmitigated try at being a toy for affluent people who want extreme adventures. So if you are jumping out of airplanes, crashing your ski-doo into pine trees, if you are driving motorcycles at 150 miles an hour, going around corners at the same time, you are a candidate to buy an Icon A5. It is a brilliant piece of industrial design. It pays attention to many of the things that go on in Good Products, Bad Products, and in fact, it's the product of two of our graduate students. These are the categories of topics which we discuss. So how do you discuss them? There are no partial differential equations. There's no matrix algebra in this course. We actually use images, video clips, and spoken and written words. The chapters in the principal reading for this course, the principal reading is a book by Jim Adams, which is called, amazingly enough, Good Products, Bad Products, Some Thoughts by Jim Adams, are Human Fit, and there's cognitive issues there, and there's ergonomic issues there, and there's additional issues there, craftsmanship, joy to the maker, joy to the user, needs and emotions, do you love it? Do you hate it? Which is better probably than blah, which is the third option. Aesthetics, elegance, and sophistication, wisdom through experience. You develop an aesthetic sense, probably not born with it through your early experience, and your sophistication level is certainly born of experience. Cultural values and symbolism, where do you come from, who are you, and global constraints, can we sustainably remain on this planet and behave in whatever way the design, manufacture, use, and retirement of the product actually represent. I'm Dave Beach. You can reach me with the following contact information, and sometimes you'll find you need to try more than once. I am notoriously inattentive to email, and since you're probably not on campus, ambushing me during my office hours probably won't work either. So the real secret is to call my administrative assistant or send electronic mail to her. Her phone number is 650-723-4287. And her email address is jenrahn, that's jenrahn @stanford.edu. I think it's only fair that you should have some sense for the personality of the instructor when you sign up for a course. We have a thing called course shopping here at Stanford, and so I feel a responsibility to explain who I am and who my TA is on the very first day of class. That's my iconic picture of me. I love my 1950 GMC pickup truck. If you happen to be working for General Motors, you deserve a lot of congratulations. This machine drives every day whenever I ask it to. It carries heavy loads, and so far it hasn't killed me through that special design feature of the steering column starts just behind the front bumper and stops just short of my heart cavity. This is Jim Adams. He's the author of the principal reading in this course. It was his course originally, and when he retired, I was distressed that it might go away because all other quality courses are about mathematics, and this one was actually about qualitative issues in quality. And since I figured it was pretty unique, I made a deal with Jim. I said, Jim, come out of retirement for 1 quarter. We'll co-teach the course. If it goes well, I'll try and take it over. And that was 8 years ago. And now I've gotten to the point where I don't want Jim to come into the classroom because I've made it my own, and I just want to have my own way in every detail. This is a course that involves a lot of discussion. It also involves writing papers, making videos, doing field research. So there are many creative opportunities in this course. The field research is driven by concepts that come from qualitative marketing, and we're very lucky to have somebody named Bonnie Wan, who runs a qualitative marketing consultancy, to launch the course originally. And she encourages getting into people's homes, maybe into their showers, maybe into their garages, to really understand who they are. She likes to ask questions like, what's your favorite music? I won't mention all of the questions she likes to ask, in order to develop a real sense for the customer. We also care a lot about the making of things. This is an image of tableware made in Sausalito, California. I happen to be a strong proponent of local manufacturing, that is domestic manufacturing. And we care a lot about design, and I will claim that this image helps you understand what we mean by elegance and sophistication in design. Made by a combination of machines and artisans. Many of the products that come out of the Product Realization Lab and that are exemplary in this course have to do with sports. Not necessarily the kind of sports that you might kill yourself doing, like jumping out of airplanes, but sports that develop real athleticism. Peter Dreisegacker founded a company called Concept 2. He now owns a lake in Morrisville, Vermont, and he is the pioneer for carbon fiber epoxy rowing equipment. He's also been very smart about creating community, and one of the things that makes a product successful is if surrounding that product is a story and community. Well, it turns out anybody who rows gets up at 5 in the morning, works really hard, knows how to experience pain, and consequently it's a pre-formed community. You can go almost anywhere in the world, and if you row, you could send a letter ahead a couple of weeks, and they would invite you to come on their Sunday row, and they'd have a banquet for you when you got back to shore. The other manifestation of this is competitions with Concept 2 ergometers are held all over the world. Stats are kept, records are distributed, awards are made. So developing community is an important part of marketing. That's the Concept 2 ergometer. It succeeds because it feels like rowing. So it has to do with what does it feel like, and that has something to do with human fit. Also has something to do with aesthetics. Margerito was the first platinum certified environmental home, LEED platinum certified environmental home in Northern California. And this is a form of design that relates to global constraints. How can we live well and still be responsible towards the environment? There's a food module in Good Products, Bad Products. Food is moderately important. Where it's grown, how it's grown, what the business models might be are one of the modules that we will address in the global constraints section. We also believe in designing for the bottom of the pyramid. Most of the people in the world live on $1 to $2 a day. They're small plot subsistence farmers, and products appropriate for them are a wonderful opportunity to look at design and design quality.
Thanks, Dave, for what I think looks to be a very interesting course. I should look into seeing perhaps if I could enroll in that class. But you know, it's one of the I don't know, truisms at any place that we all work in our own silos, and it's not invented here. It doesn't exist. But Dave and I actually, doing this webinar together, we had an opportunity to kind of revisit what each of us do in the class. And he mentioned something that hopefully we'll get a chance to come back to. If you can measure it, we're not interested in it. And let me just jump into the next slide. So I teach ME317 design methods, which, the word design certainly is something that will be covered in both of our classes. And David mentioned this airplane up near the front of his talk, a product that's getting close to production. Go ahead and hit the build slide. Thanks. So a lot can happen on the way to the market. So Dave's class is all about, if you will, identifying an opportunity or perhaps some challenges in your existing design. Well, unfortunately, fortunately, there are perhaps many opportunities when we're in the product development stages of improving the overall product, whether it be delight, cost, manufacturing capability and so forth. But there's also many ways that your product can fail on the way to market. So, for instance, for this particular airplane, there might be a great aha. This underserved market, that's the folks that are driving ski-doos or powerboats or expensive motorcycles, the extreme thrill sports lovers. Do you really understand those market requirements in terms of, the aesthetics versus the performance versus how much it costs? What is your target cost for a product such as this? The technology that goes in, you can see that this airplane has a new or perhaps unconventional architecture when we're talking about general aviation. Now, I know the ultralight sports airplane market is anything but conventional in terms of architecture, but does this concept, is it actually going to deliver in terms of the cost, reliability? Even he mentioned the FAA. They provide requirements as well that, if not fully understood before you start cutting tooling to actually make this plane, can certainly have a big impact on the relative success of the business model. So let's go to the next slide. So ME317 then is a systematic design course which essentially provides a toolbox for addressing all of these varied product requirements, whether it be something coming from the stakeholders, some sort of manufacturing challenge or opportunity, the business model, and so forth. So we have many tools in our toolbox. 317 is a experience-based, project-based course that will show you, using a hands-on real project, how to come up with a project definition with the right feature set, the right cost, with the correct time to market. Next slide. If we look at the content of the tool, we address all phases of product development. And I mentioned we are a project-based course. Any projects that you would come into the class with could be at various stages of maturity. So it could be you're still in the user and stakeholder definition stages, or you're perhaps trying to reduce manufacturing cost, improve reliability, and so forth. We take all kinds of projects And given the overall system requirements, we take you through the toolbox in a systematic way, where the customizability and where the teaching staff comes in is how you apply the tools to your particular challenge. Because each of our projects that we see that the students bring, they're going to have a different emphasis and application of the tools as we march toward that ideal embodiment of features, cost, and time to market. Okay, let's go to the next slide. So I mentioned we are a project-based course. So that means students in the class, whether you're on campus or remote, will be working on a project throughout 2 quarters. So we are a 2-quarter course, ME 317A and 317B. We start in the second week of January this year. You can see that's January 9th. We hit the ground running, and we run through the first week of June. So it's 2 quarters long. You have a project. So we're going to open up the floor to questions in a few moments. So one of the questions out there, wait a minute, where did the projects come from? There are two opportunities here. We have projects that are sponsored by companies for our on-campus and local SCPD students. So if you fall into one of those categories, you have an opportunity at the beginning of class to select a project that will be offered from anywhere from 4 to 6 companies that make their presentations what they want you to work on. If you are a remote SCPD-based student, and in fact, I think this is where the real power is, you have the opportunity to work on an internal project at your company. We, in being a very industry-focused and project-based course, we realize there are challenges with non-disclosure and company secrecy and so forth. We have no problem handling those kind of constraints in terms of using an internal project to teach the principles in the class. But the ideal case is that you do work on an internal project. It's something that you're responsible for anyway, and you can use our class then to both get further education and credit, as well as improving an internal design for the company. We run over 2 quarters. There's just a couple major milestones during the course. At the end of the first quarter, you will produce a report. There are no exams in this class. So the finals, anytime you see final up there, it's related to a final report and a final presentation. We do have plenty of homework. It's, I guess, a hallmark of Stanford Engineering project-based courses that they're not traditional in the sense of studying for quizzes and exams. Typically, you are doing a lot of rolling up your sleeves and actually working on a project, submitting progress reports in terms of homeworks, and then showing your actual development efforts through your presentation, and essentially your chance to market your product ideas. So that happens twice in terms of finals, so final presentations and reports at the end of the first quarter and the second quarter. One other thing I'll mention about this particular class, I mentioned that there is a fair amount of customization and guidance from the teaching team in terms of how you apply this toolbox to your particular project development challenge. One other hallmark of this class is that almost weekly you are making presentations to either the class or the teaching team. You're almost immediately applying the principles that you've learned in the previous lectures to your project, and you're receiving feedback. If you happen to be associated with on-campus, you're receiving feedback from the on-campus students as well as the teaching team. And we're doing the customized coaching of how you apply these methods to your particular problem, how those tools and methods work on your particular project, what you should be doing next, what are your opportunities perhaps that this particular kind of project may offer. Now, another question that comes up is, well, what kind of projects are suitable? And we run the whole range these days of the kind of projects that we see. Whether one distinction I make is hardware, like the A5 Icon airplane that you saw up at the beginning of the presentation. That thing makes a noise if you drop it, but we also deal with products that if you drop it, it doesn't make a noise. Think of something like Netflix, which is presumably a service that most of you are familiar with. Of course, if you dropped a DVD, it might make a noise, but the value proposition or the essential product of that company is a service. So from a product or a system development perspective, the analysis approach to understanding stakeholders, the business models, the potential failure modes of both your business model and the service itself or the product itself. All of those underlying principles are the same, where it really the devil is in the details in terms of how you apply particular methods to solving certain problems. So we address a wide range of product, system, and business process development type challenges in our course. So I think with that, I'm going to wrap up the formal discussion of the class, and I think at this point we're going to open it up to questions and discussions.
Thank you for participating in our presentation today and sharing your research with our audience. We're going to respond to audience questions, and while we collect your questions from the queue, I'd like to take a few moments to share information about the two courses that we'll be offering this winter quarter, taught by Professors Dave Beach and Kurt Beiter. A little bit of information here. The Stanford Center for Professional Development serves as a bridge between Stanford University and industry, offering academic and professional education courses and programs to meet the career-long education needs of engineers, scientists, technology professionals, managers, and executives. Our center has been part of the Silicon Valley, extending Stanford education for over 50 years, and based on customer feedback, having access to Stanford-level education is critical to maintaining a competitive position in the marketplace. The Stanford Center for Professional Development offers approximately 200 graduate courses each year that can be taken online for academic credit without having to be formally admitted to a degree program. We offer bundled courses or graduate certificates comprised of 3 to 5 courses in a focused guided curriculum of study, which offers not only Stanford University graduate credit but also an in-depth subject-specific knowledge. We also extend master's degrees to industry through our honors cooperative program. Candidates must apply like any other graduate student, and if admitted, can pursue their degree on a part-time basis over the course of 5 years. Up to 18 units of graduate credit earned under the non-degree option may later be applied towards a master's degree. We also offer the option to audit courses, allowing you to update your knowledge without homework, exams, or interaction with the staff. The enrollment period for winter quarter is currently open and will remain active until Wednesday, January 4th. If you're interested in enrolling in any of the graduate courses offered through the Stanford Center for Professional Development, you must do so online through our website at scpd.stanford.edu. Tuition is determined by SCPD company membership and non-membership. If you are unsure about whether your company has a membership with the Stanford Center for Professional Development or would like to learn about the benefits available to member companies, I encourage you to contact us. I would also like to highlight an upcoming webinar we have scheduled for January 18th on the topic of positive intelligence. This live webinar will talk about maximizing potential and performance in the area of project management. At this point, I'd like to conduct the final poll in our webinar. Please indicate your level of interest in the graduate courses referenced today. While you're entering your response, I'd like to ask our speakers some of the questions that we received from our audience today. Professors, one of the questions that came up was, what process do you use to validate design?
We use qualitative marketing principles, doing field research initially, and then I would advocate, but not included in the course, is prototype building and distribution for market testing.
Yeah, but I would just, extending what Dave said, prototype building is always a part of what we do, whether we're prototyping the problem or the actual solution. In our course, we start moving you much farther along in terms of business model validation. The reality of anything academic or on class is, unless you have a particular unique opportunity, it's really incubator or kind of a laboratory type experiment where we certainly encourage validation in the sense of prototyping and testing it before users and actually trying to, prototype the manufacturing processes. But the real meat, of course, and this is where you have the opportunity working in industry, is that you've taken the chances or the opportunities in an environment where you can fail. Failure is often thought of as a bad thing, but in kind of project development work we do, we look at it as a huge learning opportunity. So validation pushed mainly through prototyping and just getting it out in front of users, but it's the devil's in the details.
Kurt, I just have to add a codicil to that.
Okay.
Wonderful exposition of prototyping. I teach a course called Design and Manufacturing twice a year. It has 90 students. The first thing we do as the students march into the classroom is we stand in circus bow posture and we yell at the top of our lungs all together, "I failed." Because it's my belief that until you failed, you can't possibly learn enough to go forward.
That's awesome. All right, let's take a look at our next question. This person says, my product is very simple but has ramifications that need much thought and work. Is there a limit on how simple the product can be?
Well, from the perspective of 317, I would say no. And in fact, in terms of learning and, complexity of a project being a hindrance, this could actually be a positive. It's amazing the amount of information and analysis perspectives you can have or investigate just in a simple single component mechanical device. Things like, a one-piece can opener can have a user interface. They have a manufacturing system that goes behind making it. There's a business model behind that. There are various stakeholders that you have to consider, whether it's the end user or the traditional stakeholder we might think about. But what about folks down in purchasing? What about management of the company that's concerned about the profitability of that project? The folks that you might contract manufacture this device out to. So what I would say, if you have a simple, and that's a very loaded word in itself, if you have a simple product, I would encourage certainly looking at that as even a greater opportunity, because perhaps if you compared it to more complex products, this is something that is easier to tackle in terms of a whole design.
The final assignment in Good Products, Bad Products is a study, not a physical prototype, which looks at the product of the team's choice through the lens of function and economics, human fit, craftsmanship, needs and emotions, elegance and sophistication, cultural values, and global constraints. That's a wonderful opportunity to explore with two or three teammates, through the lens of human values, how your product might do, and to contemplate refining it in appropriate ways.
All right, here's an interesting question. Can a product be a good product at just the wrong time? Perhaps the public is not quite ready for an advanced concept due to public perception or other external factors, or would you consider that just to be a bad product?
A good product is absolutely time dependent. It's very hard to get guest speakers to come into Good Products, Bad Products and talk about their failures, but every once in a while we succeed. And there's a local company in Santa Cruz that developed an underwater camera product, which won design awards all over the world, which was clearly technical superior to anything else, but it came 18 months late to the market, and it came over budget, so the price was too high. And by that time, everybody who wanted a product in that category had already bought something from the competitor. That product, because it was late, almost bankrupted the company involved.
Yep, and just echoing what Dave said, one of the taglines on my slide was, oh, by the way, something happened on the way to the market, and that certainly the interpretation of market timing, it can, it's clear to, I think there are clear examples of arriving to market too late. That is, competition has already gotten there. Potential customers have moved on because they've found other ways to satisfy those functions and so forth. But that's interesting that releasing a product too late, that failure in that scenario can come from several different perspectives. One of the common examples that we talk about quite a bit in product development is like the iPod, and that it's an interesting, I think, thing that Apple, who was a company not particularly, that wasn't their product depth. Consumer products personal device. Obviously, they did personal computers, but there was just the right, I guess, technology arcs of miniaturization, music becoming digitized first through CDs many years ago, and then through the internet. So even the internet itself, in terms of allowing the whether legal or not, rapid and easy sharing of music. All of those arcs coming together in enabling a business model that, up until that point, had really not taken off. The Apple was certainly not the first the digital music or MP3 player to hit the market, but they were the ones that really learned how to make money at doing that. Now, of course, there's a lot of other things that went into the success of that product in terms of their marketing, their product design in terms of the fit, form, and function, and so forth. But again, that was certainly an example of timing in terms of the right technology and societal changes and other kind of supporting infrastructure arcs all reaching maturity at the right point. Just one other Apple example, they came out with a Newton, probably giving away my age. This was the early 90s, and it was much, much awaited by certainly the technological or the computer-based press. And ultimately, I guess you could say it failed as a product. I don't know. I guess you could measure that several different ways. It certainly had a very devoted following, but it was Palm, if you will, if you want to throw Newton and the Palm computing into the same market with their PDA that really was successful. And we could spend quite a bit of time discussing why or why not one product was successful and another wasn't, but certainly timing in terms of not just consumer readiness and perhaps leading the consumer to use a new product, but also just technology and can you do what you need to do with the existing technology.
A couple other examples are fun. I think my 1950 GMC pickup truck is probably not the perfect product for freeway use in California today. It was magnificent for its intended purpose, which was farm use, 60 years ago. And the Icon A5 would not exist today unless the FAA had defined the light sport aircraft category, enabling pilot training to be greatly shortened, enabling performance of small planes to go way up so they became much more attractive.
So the other question that came up is, are your courses only related to hardware products or also towards software products?
Good Products, Bad Products has traditionally focused mostly on hardware. That's where the readings are, and most of our guest speakers have launched hardware companies or have a lot of responsibility in major companies like General Motors and Ford. On the other hand, we are open to project work being done in the arena of services or environments. And we have one of the most interesting projects ever done was a redesign of a Safeway store. So students went out with their video cameras and they watched people shopping and then they interviewed people, and the whole process of what makes a good interview is an interesting one. My favorite single topic on the subject is Michael Berry, who is founder of Jump Associates, and that's their business, is need finding. He says the right way to do an interview is create a script, do your homework, really understand who you're going to talk to and what questions would be reasonable, and then you launch with your script, and as soon as the customer goes in some other direction, especially if it doesn't make sense or seems to you to be wrong, that's what you want to jump on. That's a flag that there's gold right there. And then what you want to do is just speak enough to keep the balloon in the air. The metaphor is you to tap the balloon, it floats for a long time, slowly comes back down. Try and have the people you're interviewing doing almost all of the talking. And if you can get them to the point where they're telling a story of some kind or other, now you've learned something valuable which could be used to redesign a product. This group of students redesigned the Safeway by laying out the store in a completely different way, changing the signage, and then they did an animated CAD adventure so that those of us in the audience could have that shopping experience in the redefined Safeway. And they dressed up as if they were business consultants, so they came into the classroom in pinstripe suits. Believe me, I don't see my students dressed that way normally, and they did a wonderful job of presenting to us, the clients, the executives of Safeway, the redesigned store.
Yeah, so I mentioned in my part of the presentation that things that don't make a noise when you drop them has actually become a larger part of our product population or project population over the years. We traditionally, that is 317, the curriculum comes traditionally from the plant floor. So we got our roots in Motorola, Six Sigma, and design for assembly, and that, wow, if we could just address some of these issues in the design phase, some of these manufacturing issues we're seeing, boy, wouldn't it be nice if you could fix it during design. It'd be a heck of a lot cheaper, and we get this product out on time and so forth. But over the years, and I don't think this is necessarily something that's just specific to the Bay Area. I mean, obviously we have computer industry is strong here, software, Web 2.0, Web 3.0, and so forth. Those are all kinds of things that are not physical hardware based, that is on the software side of things. And so we do see a high percentage of those kinds of products. But the other way to look at it is almost, except for what I'm thinking is an increasingly rare occurrence that you have a simple, say, mechanical-only object. Almost any, certainly consumer product these days are going to have a strong software, firmware, and service-oriented component to the overall product function. And whether we are dealing with, manufacturing that widget or delivering that user experience that's heavily supported by software, we need to be able to address design challenges, business model challenges, production challenges, and so forth, no matter what. So we, in terms of our courses, deal with, business processes, services as a business type processes, as well as hardware.
All right. Let's go on to the next question. For good products, bad products, do you discuss the design process, not just a project-based, as in the A and B class, or is it more of a survey of why certain products failed or succeeded due to the design process?
Good products, bad products has two essential components. One is inspirational, and so design process, but also business models and also personal lifestyles get discussed by a variety of guest speakers. Perhaps the most interesting person on the agenda for this year is coming from us from, what is it called, Silver Lake Equities Fund, and they have just put together a new alternative energy component, and George Soros is the major player there, and his partner in that, named Adam Grosser, will be talking to us about global constraints. So you get a notion about design process and also business process over and over again from a variety of entrepreneurs, most of whom are not famous enough that you've read their books or read about them in the Wall Street Journal, but they're just one level below, so they're very, very successful practitioners, very successful entrepreneurs whom you wouldn't get to meet in any other way. The second way in which design process is represented in good products, bad products, is through the syllabus. So the first assignment is design field research to learn something about consumers using a product or an environment or a service. And that's based on Bonnie Wan's lecture typically. The next thing to do is go out with video camera and sound equipment and observe the use of products by those people, implement your research project with the eye towards discovery. And there what you're trying to do is come up with something you hadn't thought about before. There the magic is. Something unexpected happens. The next assignment is turn that discovery into some kind of a story which would inspire or lead the design of a product or a service or an environment. And then finally, in team format, you put together final presentations, and they want to do two things. They want to have high production values. I care about lights, costumes, quality of sound, quality of images, quality of video, and anything else you may do. If you're a remote student, that will be encoded by making a video of the presentation and sending it to us. If you're an SCBT student who lives close enough to campus that you can participate on campus, then you could do things like bring food, add scent to the classroom, and so forth. So the whole notion of attention to aesthetics is very important there. The second prong in that assignment, the second thing that's highly regarded, is that you teach us something new intellectually, that you break new ground and insight into one of the Adams topics. I think all of that is correctly characterized as design process. It's different from the Hasso-Plattner Institute of design process, complementary and therefore very powerful.
All right. Our next question is, I don't have a background in mechanical engineering. Is an engineering background necessary for these courses?
Okay. For 317, engineering degree is not required. we do require a bachelor's degree, and that's, I think, typical of most of our Stanford graduate courses. The math, all the linear algebra and, differential equations, all that stuff, well, it's important in product development. It's just in 317, and I think probably in 314, it's not something that you'll be doing on your homework. There is some math in our class, but it's math with a purpose. That is, we show you what problem we're trying to solve, and it's actually, you understand immediately why you're doing it, why are we here, and so forth. Just to give you kind of a technical challenge or difficulty background, the main tool we use in our class that have anything to do with math and the technical side of things would be Excel. So whereas you could be using CAD and FEA to validate or evaluate certain defined concepts, it's not something that's required. One other thing I would put on there, in terms of putting together a project-based team, ideally you have all facets of the business perspective and just the development system perspective represented. And of course, some of that's going to be engineering, but on business side, the industrial design side of things, product management side of things, manufacturing, and so forth. So we emphasize a team-based environment, and for our remote SCPD students, that's something we can talk about, is like, how do I put together a team? But we really need all perspectives when we're talking about a product and system development.
The wonderful thing about a university is it has many departments in many fields, and it's the interaction among those professional activities that makes a university very, very exciting. I teach SCPD principally to get the perspective of people in industry. You bring a tremendous amount to the course because you're not located at Stanford in general, and that's fabulous. And if you don't happen to have a degree in engineering, assuming you have a bachelor's in something, you're absolutely welcome. The other element of diversity in good products, bad products, is we attract quite a few business students, and we are now authorized as a general engineering requirement for undergraduates. So we get a whole flock of philosophy majors and VTS majors, and the discussion is so much richer because of that diversity. I would actually be very disappointed if everybody in the course had a degree in engineering.
All right. So the next question is, how are issues of intellectual property addressed in these courses?
Okay. That is perhaps a particular challenge for any project-based class that a company, especially when a company is sponsoring a project. So two answers, or they're related. There's two parts. If you are a external SCPD student who's working on an internal company project, the IP is and remains solely the possession of the company that the student works for. Okay. If you are working in the other context, other project context, that is, I mentioned up to 6 companies may be coming in and saying, hey, we have a problem for you to work on. These companies like, Cisco, Oracle, just to give you some examples. They come and present a problem that they would like a team of students to work on. In this particular case, so we call this a project affiliate or a sponsored project, the IP is treated in one of two ways depending on what's developed. If it is IP based on an existing IP that the company already owns, that remains with the company. If it's something completely new, so the student team comes up with something that is, a new feature or a new widget, then the IP is jointly, Stanford owns it. The company has non-exclusive access to use it however they want to use it. But Stanford, if it was a case of a patentable idea, Stanford would pursue that patent. Just to repeat, this is in the case where it's a project sponsored by a company, and it's completely new IP, not based on any existing IP owned by the company. But just to also reiterate, if you are working on a project from your company, all IP remains with the company. There's no Stanford involvement at all.
There is normally not an IP concern in good products, bad products. We're not generating products. We're generating insights into existing products. If your site is nervous about sharing some project you're working on, you are free to select some other target for your final report. It may be very helpful to you to work on whatever you're doing professionally as a way of getting more efficiency from your hours invested. But we are going to present publicly whatever it is you present. and consequently you may want to choose something from somewhere else.
All right. I have somewhat of a lengthy question here, but this is an interesting one. Based on your experience, what insights can you share with us on how small to medium scale companies could best protect their new product ideas and minimize the risk that larger companies will engage in idea theft after gaining access to the prototypes developed for their prospective investors? One option is to fully secure all patents and registrations first, but that opens up the serious risks we just discussed today, that of waiting too long and releasing the product too late into the market.
That's a really tough question. I'm so glad you asked it because it gives me a chance to think and not just give an automatic answer of some kind. I think there's always a balance between sharing information and protecting information. And I think the details of where that balance lies have something to do with the size of the company, something to do with the product domain, something to do with the intended market, and something to do with the culture surrounding the organization that's developing the product. In general, my own belief is that intellectual property is absolutely critical to a startup company. They are, after all, small and relatively defenseless. They can afford fewer legal fees than the bigger companies can. And so it's especially sensitive, I think. What I observe in the world is that certain companies, I'll pick on Apple since Kurt has brought Apple up, have better security than the Pentagon does. They really, as a matter of corporate culture, pay attention to intellectual property. I, who take field trips all over the world looking at manufacturing sites, cannot get into Apple's model shop. They just won't let me in. On the other hand, I have students who have launched projects. John Stanfield, what everyone needs is a small electric, essentially a buckboard, which intends to enter the market at under $10,000 and be a utility vehicle. And his view is the more visibility he gets, the more partners he attracts, the more technology he can attract, and the better off he is. So I think that's a deeply insightful question, and you really have to look at the details of the organization to answer it.
Yeah, and I would echo that. I hate to give an answer that says, it depends, but in this case, I think it really does. When we talk about just on the logistical project-based side of things, if something is so sensitive that probably it's just better to treat that outside of the realm of 317 and perhaps 314 as well. But in terms of how we treat that in a system development process, one aspect that we cover in the class, I mentioned there's a lot of things that can go wrong on the way to market, and this could certainly be how you treat this issue could certainly be one of them. But risk analysis and how you frame the risk and your response to that is going to be part of any system development that has an exposure to this kind of risk. So that's something, there is no magic silver bullet answer. It was something that we would certainly concern ourselves with during the business development process.
Since it's such a hard question to answer, the "it depends" answer is an easy one and probably not all that helpful, though it was my offering, and Kurt has followed my lead. I'd like to point out a couple other things. So there are other ways in which a product could succeed, and one of them is quality of implementation. And so manufacturing and manufacturing quality are at least as important. Not to say intellectual property isn't important, but they're also very, very important. And I believe after many years of being a professor who was brought up in a family where anytime you bragged about yourself, you were being uncivilized, I think I finally learned that marketing is really important and that self-promotion is not an option, it's a responsibility.
Yeah.
All right, let's look at the next one. A question asks, do you cover or teach the regulatory aspects of product design and how that particular project will be regulated for regulatory quality professionals?
That has to be a question, I'm going to guess, that's based either in medical products or in the aerospace industry somewhere. And we do not teach regulatory design principles in good products, bad products. There are other courses at Stanford that address them quite well, and they tend to be medical design products.
Yeah, I mean, and that's a reality in our side of design as well. Again, it would be similar to the last question. We don't specifically teach the principles of regulatory design, but the regulatory agencies are a very important stakeholder, and dealing with them in our business development and product development process is, part and parcel of those regulated industries. So it's not the elephant in the living room, it's the elephant in the living room that we can actually see and we do have to deal with, yes.
All righty. Can individual students enroll without a team? How do individual students work on projects?
That's especially interesting for good products, bad products. You may be alone at your site, and we encourage that. And what we will do is we will have a logistics system in place to help you find 2 other team members, and they also may be alone at their sites. And that's the reality of design today. Phone calls are picked at a time of day when both in Asia and in New York, the person is still awake and possibly functional. So communication with modern digital tools is a very effective way for teams to operate in good products, bad products, and we will help assemble those teams.
Yeah, we have similar response to Dave. Yes, we support remote students and what we call remote singletons. I would say if you are a single person not in the Bay Area, so not able to attend on campus, and you would love to take 317 and you have an internal project, well, you could have 2 cases, an internal project to work on, or you would love to join an on-campus team even though you're 3,000 miles away. We can handle these on a case-by-case basis. You would just have to work with me and or the TAs to do that, where, as Dave mentioned, we would either team you up with other remotes or actually find a way where we can include you on an on-campus project. We've done that before. We've also supported single remote students working on their own project. That is possible, but we would want to handle that on a case-by-case basis. There is, I mentioned there's no finals in terms of exams, there's no quizzes, but there is plenty of project-based work to do. And working alone can be doable, but we just want to make sure that the student is clear about the requirements.
All right, that wraps up the question and answer session for today. Today's presentation has been recorded, and we will be sending out the link to all registrants. We welcome inquiries and follow-up, and we'll stay online to answer any questions remaining in the queue. You may also contact our student services at scpd-customer-service@stanford.edu, or you can call student services directly at 650-725-3016. Once again, thank you everyone for attending today, and we hope to see you in the winter quarter.
Okay. Thanks very much.